Oh, hello everyone. I'm Yu Mei, the backend engineer of Light Taiwan. I'm the team member of a product called Lightspot. We need to exchange our data to our partners, and I take the responsibility for that. So today I want to share the topic, efficient integration data from multiple data providers. Let's talk about the project Lightspot. It's a launch in the middle of June this year in Taiwan, and is an line embedded service to provide nearby shop or restaurant by user location. Not only stores-based information, but more, such as what's the mail of the restaurant, what's the price, what's the comments of each meals, and how do the users reserve the seat. So we need to help. We need to ask for the expert companies to join us to do the better service. This is the flowchart of Lightspot. User browse information through Lightspot and even make the orders. The source of information is from partners, and Lightspot need to pass the user request to partners and let the partners serve the user. So we have some practice for cooperating with partners, and I list down the top 3 rules. First one is we must provide processing data manual way because as an engineers, the intuitive way to exchange data is just turn on a server and run the program automatically. But the truth is not all potential partners have enough engineering resource. So if we keep manual ways, that means we keep the chance for those potential partners. The second practice is open source principle. It describes software entities must open for extension and close for modification. This is very important because it happens very frequently and rapidly to create and delete partners. Because in business, there are no permanent enemies and no permanent friends. So if we follow these principles, we can still keep our programs clean. And the third one is generalization and customization. Because our responsibility is to make the data consistencies for one product with different providers. Because different providers have its own different data structures. So we need to keep a flexible way to for the customize. As you can see, it's all about the maintainability of a data system. The book, Designing Data-Intensive Applications, says the maintainability has 3 factors. This one, operability, is to make the system easy for operating team to run smoothly. And the middle one is simplicity, is to make the system easy for new engineers to know the system. And the third one is involvability, is to make the system easy for change in the future. Map the top 3 rules. The operability takes care of processing data manually, and simplicity is for calling help because we have a small developers group, so we need to be able to back up each other. And the right one is involvability tests both open-closed principle and generalization customization. But fortunately, we have solution. Our solution is using event sourcing pattern to design our architecture. The main idea of event sourcing is to keep every state, every event of each operations in the system. And we use Kafka for implementation because Kafka has complete support for event sourcing. The Kafka have producers, have string processors. It can do some calculation, conversion, data conversion, and put the event back to the Kafka. And consumers and the connectors is the simple consumers which already implemented. So we can just choose the proper connectors, set the configurations, and it will run like a charm. This is the real system in Lightspark. As you can see, the producer part is like the partner dispatcher, and each partner has its own string processors to do the data conversion, and the final destination is going through the connector. On the right, on the left side, different services has its different database based on the advantage of database. For example, we want to view the POI data in a structured way in the whole picture, so we choose the MySQL. But on the other hand, if we want to view the location data, we always use search. And so we need a database is good for text search, so we choose Elasticsearch. Event sourcing pattern provide a flexible and efficient architecture because it keep the event forever and always. So we can create, replace, or delete each component without affect other components. For example, if we want to replace the Kuban DB, we can just turn off the connectors, move the DB to the new DB, and move the message offset to the very beginning, and then turn on the connectors. So apply for the top three I mentioned before. The first one, processing data manually. I only just need to. I forget to mention the manual ways. I think, for example, is implement a CSV parser. So at that part, I just need to implement a CSV parser before the dispatcher. And it can be done very simple in a very short way and no effect to other components. And the second one, open-close principle. I mean, the create or delete partners. It's also very simple. I can just create or delete the string job for the partners. And the third one, generalization and customizations. I need to do small modifications in dispatcher, point out which data is for which partners, and then all the details are in the string processors. Because each partner have its own string processor, so I can do the customization in that part. For example, I can set the default expire time for the product, and I can add the tracking code in the string processors if they want. So today, the summarize is today I shares the challenge in Lightspark is maintainability, and the solution is event sourcing. Thank you for listening, and if you have questions, suggestions, please send me the email. Thank you.